Hey everybody, welcome back to another math lesson. Today we're going to continue on with our exponential and logarithmic functions unit. So let's get started. Here's lesson 2, solving exponential equations. So we're going to recall the exponent laws. So when we have the same base, x to the power of n times x to the power of m, so same base, two different exponents, however, it's going to be written as x to the power of n plus m. Okay, so you're going to add those exponents together. Same thing for the next one. We have x to the power of n divided by x to the power of m. So same bases, different exponents. So it's going to be, in this case, x to the power of n minus m. Okay, next one, same bases again. So this one's going to be x to the power of n times m. Okay. So the next one is x divided by y to the power of n. Well, you're going to distribute the exponent in, so that's going to be x to the power of n divided by y to the power of n. X to the power of 0, as I stated in the last lesson, it's going to be 1. X to the power of negative n, well, that is going to be 1 over x to the power of n. And finally, we have x to the power of n in a fraction, n divided by m. Okay, this is going to be the mth root of x to the power of n. Okay, so that's how you distribute that fraction here. All right, so let's go through steps to solve an exponential equation. So number 1, if the bases are the same, so one base on each side, use one-to-one property. This means you can equate the exponents and solve. So if b to the power of m is equal to b to the power of n, then m must equal n. Note, it is technically incorrect math language to cross out the bases when showing your work. This is a procedural error and will result in a half-mark deduction each time. That could change depending on how your teacher assesses you and how they mark. But just note that the main part is it is incorrect math language to cross out the bases when you are solving, okay? So do not do that. If bases are different, then rewrite the equation with the same base. Equate the exponents only. So only if you have one base on each side. Use your exponent laws to make this happen, and then you solve. And finally, 3, if bases are different and cannot be rewritten with a common base, well, stay tuned. This is where logarithmic function happens. So this is where the fun. So basically, this is where the fun begins. Okay. So let's do a bit of math here. So let's do example number 1. Solve for x. So your unknown as answer. Okay. So we have 9 to the power of negative 3 over 2. So if we're going to use our exponent laws, this negative exponent we're going to change so that it's 9. Or sorry, it'll be 1 over 9 to the power of 3 over 2. Okay, well that's equal to x. So what that means is we are now going to take this fraction exponent and change it so that it's a root. So this is going to be now the square root of 1 over 9. And that's all going to be to the power of 3. And that is still equal to x. Okay? At which point the square root of 1 over 9 is going to be 1 over 3 to the power of 3. And basically one third of the power of 3 is going to be, so you can just do the top and bottom to the power of 3. That's going to be 1 over 27 to the power is equal to x. That is your final answer. Okay, that's how you use your exponent laws to solve. Solve for the unknown base this time. So before it was an unknown answer, but now we're going to have an unknown base. So it's going to be x to the power of 4 is equal to 1 over 81. Okay. So what we're going to do now is actually we're just going to get rid of the power of 4. So to do that, we will take the fourth root of both. Okay. So now we're going to have x is equal to the fourth root of 1 and also the fourth root of 81. Okay, that's how we can split apart using our exponent laws, okay? Now, with the fourth root of 1, well, that's going to be x is equal to 1. And the fourth root of 81, so what number multiplies by itself 3 times to give you 81? That, in fact, is 3. So that is your final answer. Okay? So there you go. Moving on, example 3. Solve for x. So now our unknown as the exponent. Okay, so we're going to have 2 to the power of x. So which means that we now need to switch this 64 so that they have the same basis. Okay, so it's going to be 2 to the power of x. Okay, and now we want to have the same base. So if we were to reduce 64 so that 2 is the base, we can also raise it to an exponent. So it's going to be 2 to the power of 6. Because 2 times 2 times 2 times 2, right? 2 times 2 6 times gives you 64. Which means that in that case, x is equal to 6. Because their bases are the same. Note. So a note for you. Okay? If you write this, 2 to the power of x is equal to 2 to the power of 6. And if you were to cross those out and then say at the end, oh, x is equal to 6, do not do that. Okay, do not do that. That is incorrect. That's where the half-mark deduction comes in. And that is every time you do that. Again, that's how I assess. That may be different from how your teacher may assess that. Okay, so it's best to ask them how their assessment practices are. Okay, but just note, important, do not do that. All right. Okay, let's move on. Next part. 3 to the power of x is equal to 27 to the power of 2x plus 1. So again, we want it so that it's the same base. So we're going to write 3 to the power of x is equal to, well, 27 can be broken down into 3 to the power of 3. Okay, and then we're going to multiply by 2x plus 1. Now that we have the same base, okay, we can actually drop the threes, like the bases of 3, and solve that way. So we're going to have x is equal to 3 times 2x plus 1. Well, we can now expand the bracket to be 6x plus 3. Okay, so now we just solve for x. So now we have negative 5x is equal to 3. Okay, which means that x is equal to negative 3 fifths. So there you go. Again, you got to make sure that your bases are the same. Okay, that's what's important. All right, let's try another example. So we have 4 to the power of x is equal to 1 over 32. So again, we want to make sure we have the same base. So we have 4 and 32 don't really go the same. However, we can change the 4 into 2. So this is 2 to the power of 2, right? It's still 4. I'm going to raise that to the power of x. Now, you can change the 32 into be something to the power 2 to the power of 5. Okay, so since now we have the same base, we need to make sure that it's the same. Well, technically, we don't have the same base. One is 1 over 2, right? And one is the value of 2. So we're going to change the fraction, okay, so that it's the same. So now in this case, now we have the same base. Okay, so now we can drop the base. So it's going to be 2x is equal to negative 5, which means that x must be equal to negative 5 over 2. So there you go. That's how you would solve that one. Okay, let's try D. So we have 2 to the power of 5x minus 1 is equal to 16. Again, the 16 can be rewritten to 2 to the power of 4. So we're going to write that. So it's going to be 2. 5x minus 1 is equal to 2 to the power of 4. Now we can drop the base, and so drop the bases and go, okay, well, this is 5x minus 1 is equal to 4. Add 1 to both sides. We can now get 5x is equal to 5, which means that x must be 1. Okay? So again, it's all about using your base laws. It's all about understanding how to get the same bases and stuff like that. Okay? I do believe we have one more on this page here. Okay, so we have 4x plus 2 is equal to 64x. So now we have, let's change them both. Yeah, let's change them both. So let's change it so that it's in terms of 2's instead, okay? So we're going to reduce them so that they're in values of 2. So this is going to be 2 to the power of 2, okay? And that is x plus 2 is equal to, 2, as we said earlier, 2 to the power of 6 to the power of x, okay? So now, since our bases are the same, we can now drop the bases, okay? So this is going to be 2 times x plus 2 is equal to 6x, 6 times x. Okay, so if we were to expand the bracket, we would get 2x plus 4 is equal to 6x. If we were to move the 2x onto the other side, okay, so if we were to do that, so again, if you can't see that, so I'm going to minus 2x here. Okay, and now I would get 4 is equal to 4x, which means that x must be 1. Okay, f. So that's the next page. We have 3 to the power of x times 27 is equal to 81 to the power of 2x plus 1. So let's make these all into the powers of 3. So let's make 3 the base, okay? 3 is common between them, so this is going to be 3 to the power of x times 3 to the power of 3, which is equal to 3 to the power of 4 times 2x plus 1. Now, when we have the same base and you're multiplying, that's the first rule we looked at, you're going to add them together. So this is going to be 3 to the power of x plus 3 is equal to 3 to the power of, and if we were to actually multiply all this through for your, on your right side here, it's going to be 8x plus 4. So now we can drop the bases and go, okay, well this is going to be x plus 3 is equal to 8x plus 4. Okay, so if we were to move all our x's to one side and move the numbers to the other side, so again, if you can't quite see this, so minus 3, okay, and then minus 8x. All right, we would get negative 7x is equal to 1. Divide both sides by negative 7, you get x is equal to negative 1 over 7. So there you have it. Okay, just a few more examples and that'll be the end of the lesson. So again, same idea. We have 2 to the power of 3x multiplied by 4 to the power of x minus 1 is equal to 1 over 8, and that's raised to the power of x plus 2. So we want to change it all so it's one singular base. So in this case, it's going to be 2. So we have 2 to the power of 3x multiplied by 2 to the power of 2 to the power of x minus 1 is equal to, this is going to be 1 over 2 to the power of 3, okay, to the power of x plus 2. Okay, so now we're going to do a bit of multiplying here. So this is going to be 2 to the power of 3x multiplied by 2 to the power of 2x minus 2 is equal to 2 to the power of negative 3 x plus 2. Okay, so now we can combine some more. So we're going to go 2 to the power of 3x plus 2x minus 2 is equal to 2 to the power of negative 3x minus 6. So now what we can do is we can drop all the 2's. We drop the powers or the bases of 2, and we're just going to write it as 3x plus 2x minus 2 is equal to negative 3x minus 6. Okay. Oh, we can combine like terms here. So this is now can be rewritten as 5x minus 2 is equal to negative 3x minus 6. Move the negative 3x to the right or to the left side, and move the negative 2 to the right. So we'll get 8x is equal to negative 4, which means that x must be equal to negative 1 over 2. Okay, so there you go. All right, 2 examples left, and that's it. So we have, this one is 4 to the power of x plus 1 is equal to 2 to the power of x multiplied by the square root of 2. So in this one, we're going to have to change the root into a fractional exponent. So this is going to be 2 squared x plus 1 is equal to 2 to the power of x multiplied by 2 to the power of a half. Okay, so now what we can do is we can drop, okay, we'll drop all of the bases of 2. So this is going to be 2 times x plus 1 is equal to x plus 1 over 2. Okay, so now when you expand it, you get 2x plus 1 is equal to x plus 1 over 2. Oh, sorry, this should be x plus 2, my mistake. Okay, so you're going to move the x to the left, and you're going to move the 2 to the right, which means you should get x is equal to negative 3 over 2. Okay, last one. So we have 1/2 to the power of negative x squared is equal to 8 to the power of 2x minus 3. Okay, so we're going to change again all of these into the power of, or sorry, with the base of 2. All right, so we're going to change that. We're in a base of 2. So it's going to be 2 to the power of negative 1 to the power of negative x squared is equal to 2 to the power of 3 and then 2x minus 3, which makes this 2 to the power of x squared is equal to 2 to the power of 6x minus 9. Okay, so we drop the bases of 2, so it's going to be x squared is equal to 6x minus 9. Move everything to the one side. The reason being is because now we have an x to the power of 2. So now we're going to move everything to one side. So now it's going to be x squared minus 6x plus 9 is equal to 0. Okay, now we factor. All right, so we're going to factor so that we get, okay, so it's going to be x minus 3. X minus 3 is equal to 0, which means that your x must be equal to 3. Okay, so there you have it. That is solving and analyzing exponential equations and using your exponent laws to solve. Okay, so that's it for today's lesson. I hope you enjoyed it. But as always, when it comes to math, keep calm and show your work.